Hi guys, good evening. It's evening, right? Yeah, evening. So we are starting the heat question bank, right? So I hope you have gone through the questions and bit of a very bit of a tough questions are there. So we will anyway manage to answer them and we will discuss the theories on the way, right? Okay. Anipathamal. Right. Right. Right? Kalau paing gitu deh. Kamera. Hedi. Kamera ada paing gitu tuh. Hedi. Mati ya. Ya, tahu. Right. So which answer gives the correct value for the extensibility or expansivity? Beta and gamma. The Y usually stand for gamma, right? If its linear expansion is 1.2 into 10 to the power minus 5. So if the linear expansion is 1.2 into, just hold on a second. Put it. Hello, put it. So if the linear expansion is 1.2 into 10 to the power minus 5, they are asking for the area expansion and the volume expansion, beta and gamma. Right? They are asking for the area expansion and the volume expansion. So what is the theory here? So beta is 2 times alpha and gamma is 3 times alpha. Yeah. So it's easy. 1.2 into 2 is 2.4 into 10 to the power minus 5 and gamma is 3.6 into 10 to the power minus 5. This one, right? Answer 4, is it? Answer is 4, right? Beta is 2 times alpha and the gamma is 3 times alpha, right? Right. So the next question, second question, an aluminium plate has a rectangular hole of area 1 centimeter. It should be square centimeter. So 1 square centimeter. If the linear expansion of the aluminium is 2.5 into 10 to the power minus 5, the area of the hole when the temperature is increased by 20 degrees of Celsius, right? So if the linear expansion of the aluminium is 2.5, the area of the hole when the temperature is increased by 20. So they are asking for the final area, right? Final complete area. So the final complete area, what is the formula for that? They are asking for the, like, there's a hole, right, in an aluminium plate, something like this. They are asking for the final area. So there's an aluminium plate. So there's an aluminium plate and a hole inside it that is 1 square centimeter in size. And they're heating it up. So they are asking for the new size of the hole, new area of the hole. So that's the final area we have to find. Why I'm telling this is, like, there are two equations. One is delta A, which you find the amount that expand extra than the initial, that is final minus initial, right? Extra expanded area, and A1 equals A naught times 1 plus beta theta gives the final area after the expansion, the final complete area, right? So in this case the question is actually asking for the final increase the complete area, isn't it? So that is A1, right? That is A1. So they are asking for A1 equals A naught times 1 plus beta theta, isn't it? This is what they are asking for. So the first thing is you have to understand if they are asking for delta A or A1. Delta A is the difference of A1, the final and the initial, the amount that was extra increased. And A1 is the final area, which is the complete area expanded at the end. Yeah, right. So values A naught is how much? It says A naught is 1 square centimeter and the expansivity is 2.5 into 10 to the power minus 5. They are increasing 20 degrees of Celsius of temperature, right? So if I apply it, apply in square centimeters, the answer will be in square centimeters as well, because these two are cancelling out each other, right? So when the things are cancelling out each other, the value, sorry, the unit that you put here will give the same unit of an answer. Get it? So if you applied meters here, you get a meters answer because they cancel out. Get it? A to A cancels out. When they are cancelling out, if you apply centimeters, you get centimeters of answer. If you put meters, you get a meters of answer, right? But if they were like the additions that the units are not completely cancelling off, so you have to put the standard or the unit designated to it, right? So if the units are cancelling out, you don't have to apply the standard units. Get it? You don't have to apply the SI units. Here in these cases, the unit you apply here will come to the answer here. Get it? So if you are applying centimeters here, the answer will be in centimeters, right? So this is 1 plus beta is, was it alpha or beta given? Alpha, right? So it's 2 times this, 2.5 into 2. That will be 5 point, right? 5 into 10 to the power minus 5, and the temperature difference is 20 degrees. This is the whole thing. So you can find A1, right? So if you multiply this thing, it will be 1 times, there is 1 square, like let's just multiply it. 1 times 1 is 1 plus 1 times this is, it's the same, 20 into 5 is 100. So 100 into 10 to the power minus 5 will be 1 into 10 to the power minus 3, because the 2 of the zeros are cancelling out, isn't it? So the final answer will be 1 point, how many zeros are there? 1, 2, 1, 2, 3, yeah, square centimeters. This should be the answer. This is the final area you're supposed to get. Get it? Yeah. .001 square centimeters. Understood it? And you got the answer correct? Yeah? Didn't do it?
I did, so I don't have the tube with me because it's in the box. So that's why I asked you for the question back 2 again.
Yeah.
Then again I didn't do it.
Doesn't matter. So now tell me the tubes you want. Yeah. Question bank 2 and the electricity and all the other tubes at once, like in the middle of the week. I'll keep them printed. Yeah. Not yet. No, not yet. Few of the things are there to print, like තව PPC එකකින් හදාගෙන යනවා. questions තව add වෙන්න තියෙනවා. ටිකත් අපි add කරලා ඕන. go. ඒ ටික මම දීලා තියෙන්නේ. ඒ කියන්නේ type කෑම් දීලා තියෙන්නේ. ඒ ටික ඇවිල්ලත් තියෙන්නේ. ඒ ටික corrections වලට දෙන්න ඕන. මට ඒක දෙන්න බැරුණා අතට. මෙයාට දෙන්න ඕන අපි රයන්ට ඈ. පුළුවන්. ඒක corrections ටික දාගන්න තියෙන්නේ. මම ඒක forward කරන්න රයන්ට. මට චුට්ටක් මතක් කර message එක දාන්න. Right. So the third question. A brass ring with a linear expansion of 1.9 into 10 to the power minus 5 Celsius has an inner radius of 2 centimeters. Right. how much temperature difference should be the brass ring be subjected to in order to send a sphere of diameter 4.02 centimeter through this? Do you understand the question? There's a brass ring and you have to send a sort of a spear through it, right? So the brass ring has a 2 centimeter radius, which is 4 centimeter diameter. How much temperature difference should be brass ring be subjected in order to send a sphere of diameter 4.02 centimeters through this? So the sphere has diameter of 4.02, right? So what do you have to do here? What you actually have to do here is, there's a brass ring, right? Radius is 2 centimeters. Well, that means the diameter is 4 centimeters. Get it? That's a brass ring. This is the ring. And there's a spear, and it has like how much of a diameter? There's a spear which the diameter is 4.02 or something, 4.02 centimeters. So can you put this spear through the ring now? Can you? No, right? Because the diameter is too small. This is too large. So what do you have to do? You have to increase the diameter of this one, so the spear can easily get through it. Yeah. So how do you increase the diameter? You heat it. Simple as that. So they are asking like how much of a temperature difference is needed to increase the diameter of this so that the spear can easily go through it, right? එතකොට ස්පියර් එකට මේකෙන් යන්න කොච්චර ටෙම්පරේචර් එකකට හීට් කරන්න ඕනද කියලා අහන්නේ අපිට එක්ස්පැන්සිවිටි එක දීලා තියෙනවා. එතකොට අපි කොච්චර හීට් එකකට ටෙම්පරේචර් එකකට හීට් කරන්න ඕනද කියලා අහන්නේ. එක්ස්පැන්සිවිටි දීලා තියෙන්නේ. මොකක්ද අපි ගන්න කන්සිඩරේෂන් එක කොච්චරක්ද මේක ඇත්තටම ලෙන්ත් එක ඉන්ක්‍රීස් වෙන්න ඕන? අන්න හරි. මෙයාව තව කොච්චරක් ඉන්ක්‍රීස් වෙන්න ඕනද? 0.2. අපිට ඕන 0.02. ඔව් 0.02 වැඩි වෙන්න ඕන. එතකොට යන්න පුළුවන් ලේසියි. ඒක අපි දාන්නේ කම්ප්ලීට් රින් එකටද, ඒ කියන්නේ ඩයමීටර් එකටද නැත්නම් 0.02 කියන අර ඩෙල්ටා L එකටද? අපිට ඉක්වේෂන්ස් දෙකක් තියෙනවනේ හැමතිස්සෙම. ඩෙල්ටා L එකක් තියෙනවා. ෆයිනල් ලෙන්ත් එකක් තියෙනවා. ඩෙල්ටා L එකට දැම්මම ඇත්තටම ලේසි. ඒතකොට ඩෙල්ටා L එකට දානවා නම් දාන්න ඕන 4.02ද 0.02ද? 0.02 වලට දාන්න ඕනේ. එහෙනම් අපි ඩෙල්ටා L එකට දැම්මම දාන්න පුළුවන් ලේසි. ඒතකොට ටෙම්පරේචර් ඩිෆරන්ස් එක ගන්න පුළුවන්. ඩෙල්ටා L equals L naught alpha theta, right? So delta L should be 0.02 centimeters. Initial length is how much? How much is the initial length? 4, because you are applying to the ring, ne? Or ring එක නේ 4. Oh, circumference එක ගන්න එපා. circumference එක ගන්න එපා. diameter එක වැඩි කරන්න ඇති. අපි අර හෝල් එක ගත්තෙත් එහෙමනේ. හෝල් එකේ මුකුත් නැහැ. diameter එක ගන්න කෙලින්, right? එතකොට diameter එක මොකද්ද? 4. මොකද මෙයාව තමයි අපි heat කරන්නේ, නේ? So it's 4. So this is 4 centimeters. This is centimeters and this is centimeters as well. So no worries. They will cancel each other and the answer will be the same. And the alpha is what? 2 point? How much? 1 point? Okay. 1.9 into 10 to the power minus 5. And temperature difference is delta theta. Right. So simplify this. You can see easily find the delta theta now. Can you try doing this and put the answers? Tuna, what's the value? हाँ ආන්සර් එක තියෙන 264 ඔයාලට වැලියු එක කීයද දෙන්නේ 263 point කීයද that's okay අර approximate answer එක ගන්න නෑ එච්චර ඉන්නේ මේක තමයි 263 something තමයි ඉන්නවා එච්චර එන අර ඩෙසිමල්ස් පොඩ්ඩක් එහාට මෙහාට වෙලා ගත්තේ වේ මේකද 263 point bro bring some calculators with you you can tell me the answer please what do you get the answer මේක නෑ ඩෙසිමල්ස් එක තියෙන්නේ 63 point Seven point? No. Uh-huh. අරගෙන ඒක 0.02 එක ඩිවයිඩ් කරන්න ඕනේ යාගේ. එකයි පහයි. So approximately it's 260. Right? Right. So next question. Yeah. Understood it? Yeah. So simplification errors can be there. That's okay. So the fourth question: two circular holes of radius A are cut in a thin metal plate of uniform thickness. The distance between the centers of the hole is x. If the linear expansion of the metal is alpha, the new distance between the centers of the two holes when the temperature is raised from theta. Right? That will be what? What is the formula should you apply there? So what does it say simply? Two circular holes of radius A are cut in a thin metal plate of uniform thickness. The distance between the center of the hole is x. The linear expansion of the metal is alpha. The new distance between the center of two of the holes when the temperature is raised from theta. So it's this is what they are asking. So there are like there's a plate and there are two of the holes which has a of a radius, right, which has a of a radius for each other, and the distance between two of the centers is how much? That is x, right? Distance between two of the centers is x. Yeah. So they are asking if the temperature was increased by how theta, right? If the temperature was increased by theta, what is the new distance between the centers, right? What is the new distance between the centers? So do we have to consider this A, the radius? No, right? Doesn't need to. Even A wasn't there in the answers. Oh, linear expansion එක දාන්න. So what is the linear expansion here? L1 equals L naught is what? X times 1 plus alpha theta. So it's x times 1 plus alpha theta. එකම නේ දෙකම මේ දෙකින් ඕන එකක් ගන්න. X times 1 plus alpha theta, right? Oh, I have forgot my specs. Right? Harida. So come to this question. A vessel of volume Vg contains a volume Vm of mercury. The volume expansion of glass and heat are gamma g and gamma m respectively. If the empty volume of the given vessel remains constant at each temperature, then Vg over Vm will be equal to what? So the actual hint the question has given is this: if the empty volume of the given vessel remains constant, you have to consider this, right? So there are two of the materials, the vessel and the volume of mercury. Two of the materials are there and they will, expand differently, right? But the question is asking to remain the remaining space constant, which means, let's say there's a remaining space between the vessel and the volume of mercury. There's a volume of mercury like this one. I'll draw it. So now let's say this is the pot or something, right? And this is mercury, right? So this is the remaining volume, empty space, yeah? So the volume expansion of, volume of the vessel is Vg, volume of the mercury is Vm, and even the expansions are given, right? What are the expansions? Gamma g and gamma m. Gamma g and gamma m. So it's gamma g and gamma m, right? These are the expansivities, right? So the question is asking the ratio between gamma g and gamma m if the in any temperature. Gamma, like the ratio between gamma g and gamma m at any temperature, right? If the empty space remains constant. Empty space constantly remain when any temperature එකකදී කියන්නේ ඔයා කොච්චර heat කරත් මේ empty space එක constant. එහෙම වෙන්න නම් gamma g and gamma m වල ratio එක equal වෙන්න ඕන මොකද කියලා තමයි අහන්නේ නේ. ඔව්. expansivity
glass එකේ මේ මොකද වෙලා expand එකේ දෙකම equal වෙන්න ඕනේ. අර constant තියෙන.
ඔව්. empty space එක constant වෙන්න නම් expansivity is equal වෙන්න ඕන. අපෙන් අහන්නේ එතකොට අන්තිමට gamma g over gamma m වල m equal vg over vm equal වෙන්නේ මොකකටද කියලා නේ. So the simple theory is this. Now think in terms of this. Let's say the vessel expands and the gamma g is greater than, like let's say the expansion of the vessel is greater than the mercury, right? Expansion of the vessel is greater than mercury. So what will happen now? What will happen to the empty space? Empty space will increase, right? Because the vessel expands more, the mercury expands less, so the empty space will be increasing, isn't it? What about the other way around? If the expansivity of the mercury is greater and the expansivity of the vessel is less, what will happen now? The empty space will actually decrease, isn't it? The empty space will actually decrease. So they are asking to contain a constant empty volume, right? What should you do to contain a constant empty volume is the question. දෙන්නම එකම ගානට expand වෙනවා. So the expansivity should be equal. So delta v's, right? Delta v's should be equal. Like delta v of glass should be equal to the delta v of mercury, isn't it? If these two are equal, then the empty space will remain constant, isn't it? So apply the values to this. So delta v is v naught gamma delta theta, isn't it? So it's Vg, the initial volume, and gamma g is the volume expansivity, delta theta is the temperature difference. And of mercury, Vm is the initial volume, gamma m is the volume expansivity, delta theta is the temperature difference. So you can easily cancel out these two, right? You can easily cancel out these two. And they are asking Vg over Vm ratio. So the Vg over Vm ratio should equal to what? Gamma m over gamma g. Gamma m over gamma g, right? Yeah. ඔව් ඒ ටික අපි ඩිස්කස් කරමු. ඒක තාම ඒක ඕන ඒක ඕන. හරි. ඒ ටික අපි ඩිස්කස් කරමු. ඔව් අන්තිම කෑල්ල. yes. ඒක තියෙන. හරි. we will discuss it. right. ඒක මේකෙත් අන්තිම හරිය තමයි questions තියෙන්නේ. අපි questions හරියට ආවම පස්සේ ඒකත් එක්ක ඩිස්කස් කරමු. right. Right, come to the question number 6. A metal sphere floats with its center level with the surface of a liquid at room temperature. Volume expansion of liquid is greater than volume expansion of metal. The center of the sphere when the temperature is raised, right? So there's a sphere. There's a sphere, and the question says metal sphere floats with its center level with the surface of a liquid. So it levels with the surface of the liquid. This is the surface of the liquid, and the center is level with it, right? And it's at room temperature. If the volume expansion of liquid is greater, rho L is greater than the volume expansion of metal, than rho M, right? The center of the sphere, when the temperature is raised, the liquid level, the liquid is level with the surface. First the liquid moves up and then down the surface. First the liquid moves down and the surface, and then moves up. So what will happen to the center? Would it go down? Would it go up? What will happen? Rho? These are expansivities. Expansivities. Question says the expansivity of metal is less, expansivity of liquid is more, right? So මේක තමයි කිව්වේ. මේ දෙන්න ගැන තමයි කිව්වේ. Expansivity. Gamma L. Yeah. Is for real. Gamma L is greater than gamma M, right? So you have to find what will happen to the center when the temperature is increasing. What will happen to the center? Would it go down? Would it go up? Would it first go down and then go up, sort of a thing? Huh? Center go down, why? Yes, liquid expansion එක වැඩි වුණාම පස්සේ liquid එකත් එක්ක උඩ යනවා වගේ එකද කියන්නේ? Okay. You actually have to consider the densities, because what defines if it goes up or down, if it is to be float or to sink, is actually density, right? Density defines it. If the density increases, if the density increases, if the density of the liquid increases, the sphere will go up. If the density of the liquid goes down, or the density of the liquid is decreasing, the sphere will actually go down, which means like it will sink. So you have to consider if the volume of the liquid is increasing or decreasing compared to the sphere, right? So here it says rho L, sorry, gamma L is greater than gamma M, right? So gamma L is now high, which means like it's එතකොට volume එක වැඩි වෙනවා, වැඩි. ඒ කියන්නේ liquid එකේ density එක අඩු වෙනවා more than metal. ඒක තේරෙනවද? Rate of decreasing the density of the liquid is greater than the rate of decreasing the density of metal. ඇයි? liquid එකේ volume එක වැඩි rate එකකින් වැඩි වෙනවා නේ. liquid එකේ density එක නැත්නම් liquid එකේ volume එක වැඩි rate එකකින් වැඩි වෙනවා. yeah. ඔව්. දැන් මේක වෙන්නේ අනිත් පැත්තනේ. volume එක වැඩි වෙනවා, density එක අඩු වෙනවා. ඒක liquid එකේ වැඩිපුර වැඩි වෙනවා. ඇයි එයාගේ expansivity එක වැඩි. ඒ කියන්නේ sphere එක මොනවා වෙනවද? sphere එක යට යනවා. එහෙනම් center should go down and ඒක යට ගිහලා උඩ එන්න පුළුවන්ද? බෑනේ. එක්ස්පැන්සිවිටි එක තියෙන්නේ හැමතිස්සෙම මෙයාගේ වැඩි අරයාගේ අඩුයි. තියෙන්නේ න අඩු වෙන එක තමයි. නේ? ඒතර මොකද වෙන්නේ සෙන්ට් එක the center of the sphere when the temperature is raised. සෙන්ට් එක පල්ලෙහාට යනවා. එයි මේක සිංක් වෙනවනේ. මේක අහන්නේ fluid level එකද center එකද? The center of the sphere when the temperature is raised. Center of the sphere goes down. අර surface එක උඩ යනවා. So the liquid is level with the surface. No. The first the liquid moves up and then down. No. First the liquid moves down, then surface and then moves up. No. Liquid moves only upward from the surface. නේ? හරිනේ. liquid එක මොකද වෙන්නේ? උඩ යන එක විතර නෙවෙන්නේ. ඒ කියන්නේ center එක පල්ලෙහා යනවා. ඒ කියන්නේ liquid එක උඩට යනවා කියන එක. Fluid moves only downwards නෑ. So the answer should be 4. Liquid moves only upward from the surface. නේ? liquid එක surface එකෙන් උඩ යන එක විතරයි වෙන්නේ. Right? Understood it? Yeah? Understood it? Sure? Looks confused though. You want it to get explained again or is still? You get it? You understood it? No. Just still? Yes or no? Huh?
Density increases, volume decreases.
Yeah.
Volume increases, density decreases.
Yeah, because density equals what? Density equals mass over volume, isn't it? So when the volume increases, density decreases. So we have to compare two. One is the density of liquid. The other one is the density of the sphere. Right? I'll take it as M. Metal, let's say it's a metal sphere. So mass over volume. So now as per this one, the volume expansion of liquid is high and the volume expansion of metal is low. So high amount of volume will expand in the liquid. So the volume will increase. So the density will go down, right? Let's say this is 10 times going up. This is 10 times going down, right? Here it's the same thing happens in the, I took it, so this is liquid, this is metal, right? So in the metal it happens the same, right? It happens the same. In the metal its volume is increasing, right? So the density should go down, but compared to the liquid it will go sometimes maybe 5 folds, right? It will go 5 folds. So this will go 5 folds of a density down. Yeah, still the density is decreasing, but the magnitude is high in liquid than the metal, right? That's the difference. Get it? දෙන්නගෙම density එක අඩු වෙනවා. හැබැයි metal එකට වඩා liquid එකේ density එක අඩු වෙනවා වැඩි. එතකොට metal එක මොනවා වෙන්න ඕනද? It should sink නේ. එතකොට center එක කොහෙටද යන්න ඕන? යටට. ඒ කියන්නේ surface එක උඩට යනවා. ඉතින් fourth answer එක විතරයි එහෙම කියන්නේ liquid moves only upward from the surface. නේ. surface එකෙන් උඩට යන එක විතරයි වෙන්නේ. Right. density of water at 0 degrees of Celsius when heated slowly to 100 degrees of Celsius, right? Density of water at 0 degrees Celsius to 100 degrees of Celsius. Tell me what happens. Make a podi theory එකක් තියෙනවා, we didn't discuss it, but it's something you should know. There's an expansivity difference in water. Did you know that? It's only there in water. That's a quality only the water wears. I'll explain it. Right. So when it comes to this water, usually what happens now? Tell me, when the temperature is increasing, volume supposed to be what? Increase. When the temperature is decreasing, volume supposed to be decreasing, right? But what happens in ice? So let's say you're putting water, mouthful, in a refrigerator and takes it in the next day, opens it in the next day, opens the fridge in the next day. What would you see? Have you done it before? No? Oh, defreezer එකේ දාලා තියෙනවා. එතකොට මොකක්ද වෙලා තියෙන්නේ? Anything else? Bottle will actually crack. Ne? Glass දැම්මොත් පුපුරන අනිවාර්යයි. Right? So what happens there actually? What happens there actually? So when the ice is, the water is converting into ice, the volume is actually expanding, right? Volume is actually expanding, right? When the water converts into ice, volume is expanding. But actually the opposite should happen, isn't it? When the temperature is decreasing, it should shrink, right? When the volume is decreasing, when the temperature is decreasing, the volume is supposed to be decreasing, isn't it? That's usually what's supposed to happen. But in water, when the temperature is decreasing, the volume is actually increasing, and it's a very good thing. Why? Because the volume is increasing, what will happen to the density? Density will decrease. Therefore, ice floats on top of the water. What if it wasn't? Ice will sink. And what if the ice sinks? Huh? There will be no livings in the water when it comes to the winter, isn't it? Because it will completely freeze. Now when it's freezing, it's only the surface that is freezing, right? When it's freezing, it's only the surface that is freezing. So let's say a pond is there, it's in the winter, and when the ice is forming, freeze. What happens this is like ඒගොල්ලෝ freeze වෙනකොට they will create a layer of ice floating on top of it, and this will act as a heat insulator, that there will be no more further heat lost from the water. Why? This is a barrier now. So there is underwater plants and the fish are here, right? So the heat in the underwater won't be losing to the environment because there's a barrier there. Get it? And that is because of the different expansivity of the water. Only the water does it. None of the other things are doing it. Get it? So when you are heating it up, what will happen? The volume will actually decrease for a certain temperature, and after that temperature it will start back to increase again. Get it? When you are like heating it up to 100 degrees of Celsius, it's expanding, right? It only happens when it's icing. Okay. So for a certain temperature, when you are heating the ice, it will start to shrink, and after that certain temperature it will again expand. Get it? It will again expand. It's something like this. It increase, so density of water at 0 degrees of Celsius when heated slowly to 100 degrees of Celsius. What will happen? Firstly, it will decrease the volume. It will decrease the volume for a certain temperature, and after that temperature it will increase back again. So gradually decrease to a minimum and increases again. So that's answer 5 in the middle, right? Answer 5 is marked in the middle, but the answer is 5. This one. Okay. එච්චර ලොකු මේ කරන්ට් එකක් යන්න බෑ. සෝල්ට් නැහැ. සෝල්ට් වෝටර් වලට යනවා. යනවා. ඔව්. මරන්න පුළුවන්.
මේ ෂිප් එක ගියත් අමුණ ගන්න.
ඔව්.
ඒකට
ඒවේ ගොඩක් වෙලාවට මෙටල් තියෙනවා නම් මෙටල් එක දැන් සර්ෆේසස් වලට වදින ඒවා සර්ෆේස් ඩැමේජ් එකක් වෙනවා වෙන්නේ නැති නේ. ගොඩක් අර මෙටල්ස් වගේ තියෙනවා නම් මෙටල්ස් වල සර්ෆේස් එකට යනවා ඒ තියෙන ඉලෙක්ට්‍රික් චාර්ජස් ඔක්කොම. ඒතර අර කෝ එකට ඉෆෙක්ට් එකක් වෙන්නේ නැහැ. ප්ලේන්ස් වලත් එහෙමයි. ප්ලේන්ස් වලත් මේ එහෙම වැදුනට ප්ලේන් එකට ලොකු කියන්නේ පොඩි අකුණක් හොඳේ. ලොකු අකුණක් වැදුනොත් ක්‍රෑෂ් වෙනවා. පොඩි අකුණක් වැදුනොත් ඉතින් එයාගේ සර්ෆේස් එකට යනවා චාර්ජස් ටික. ඒ හින්දා තමයි සාමාන්‍යයෙන් ප්ලේන් එකක් ලෑන්ඩ් කරාන් පස්සේ මොකද කරන්නේ? ප්ලේන් එකක් ලෑන්ඩ් කරාන් පස්සේ ආව අර්ත් කරනවා. අර්ත් කරනවා. ඒ කියන්නේ වෙනම කම්බියක් අරගෙන එයාව පොළොවට සම්බන්ධ කරනවා. එතකොට අර එයාගේ මොන හරි ඉලෙක්ට්‍රික් කරන්ට් එකක් චාර්ජස් තිබ්බනම් මොකද වෙන්නේ? ඒ ටික නියුට්‍රල් වෙලා යනවා. මොහොතේ හැම වදින්න පුළුවන්. ඈ? වදිනවා. ගොඩක් අය ලොකු අකුණක් වැදුනොත් නම් ඉතින් අර කන්සෙප්ට්ස් අදාළ නැහැ කුඩු වෙලා යනවා. ඒ අකුණක තියෙන ලොකු පාව එකක්. ඒකට ඉතින් අර ඉන්සියුලේටර්ද මොකද අකුණක් එන්නේ සාමාන්‍යයෙන් ලොකුම ඉන්සියුලේටර් එක හරහා. මොකද ලොකුම ඉන්සියුලේටර් එක. එයා. ඉතින් එයා ත්‍රූ වෙන එකක් නිකන් මේ ලී කෑලි රබර් කෑලි දෙක අතර වෙන්නේ නැහැ නේ. කෙලිම එයා ත්‍රූ වෙනවා නම් ඉතින් අනිත් ඒවා අදාළම නැහැ. කුඩු වෙලා යනවා ඉතින් වැදුනොත්. ගෙවල් වලට වැදුනාම හොඳට ඉන්න කවුද? එන ගෙව්වත් ගානක් නැහැ වගේ එකක්ද? ඈ? ඈ? ඇස්බෙස්ටොස් ඉන්සියුලේටර්. වහල වල දාන්න. සාමාන්‍ය ඉස්සර දැම්ම ඉස්සර අපේ ගෙදරත් ඇස්බෙස්ටොස් තිබුණා පොඩි ගා. ඒවටත් කියන්නේ ඉන්සියුලේටර්ස් ඒවා ඉතින්. එහෙම නැහැ ඉතින් අකුණක් වැදුනොත් ඉතින් ඉන්සියුලේටර් කියලා ඒවා දාන්නේ. හදාගෙන යනවා. ඔව්. හරිද? Right, come to the 8th question. මේක හදන්න තනිය. A container made of material of linear expansion alpha has a volume V at room temperature. The volume of liquid whose volumetric expansion gamma can be placed in the container at any temperature with the volume of empty space of the container remaining constant is. It's the same like the pot. අර අපි pot එකක් ගැන කතා කරේ. Empty space එක constant තියෙන. It's more like the same. Try doing it. Found it? Found the answer? Yeah. True. So what does the question say? A container made of material of linear expansion alpha has volume V at room temperature. The volume of liquid whose volumetric expansion gamma can be placed in a container at any temperature with the volume of the empty space of the container remains constant, right? So there's a container and there's a bit of a volume in it, a container made of material of linear expansion alpha. So material's linear expansion is alpha and has a volume at V. Volume is actually V, the room temperature. The volume of the liquid whose volumetric expansion is gamma. Volumetric expansion of this is gamma, can be placed in a container at any temperature with the volume of empty space of the container remaining constant. So they are asking for the volume actually, right? They are asking for the V. So it's the same, isn't it? So the empty space to be constant, delta V of the liquid should equal to the delta V of the container. I'll take it as M, or container in the sense C. So now delta VL should be how much? There is L naught gamma theta, and of the liquid we don't know, we'll take it as VL, initial volume, right? And the volume expansion is gamma, it's given. Take the temperature as delta T. Here the container's initial volume is given V, right? And the expansivity alpha is given, this should be 3 alpha. And the temperature difference is delta T. So you have to find VL, right? You have to find VL. So isolate VL, that's all. Delta T to delta T will cancel out. So VL should equal to, but 3 times V alpha divided by gamma. 3 times alpha V divided by gamma. Right? Should be the answer. Yeah.
සර් උමතර බෝල් එකකට අර කූලර් එක දැම්මා ඒක මේ කූල් එක තියෙනවනේ.
කූල් එක තියෙනවා කියන්නේ එතකොට අර හීට් එක යනවා කූල් වතුර වලට. ඔව්. 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 තව ෆ්ලාස්ක් එක පුළුවන්. ඔව්. කූල් එක නැති වෙන්නේ නැහැ. ඔව්. පුළුවන්.
මේ අයිස් කර දෙන්න තියෙන්නේ.
ඒත් තියෙනවා.
අයිස් කර දාලා බුදුනානේ.
මොනවා?
බුදුනානේ.
ඒ සමහරක් වෙලාවට ඇතුලේ තියෙන එයා එක මේ ශ්‍රින්ක් වෙනවනේ. අයිස් කැට දැම්මහන් පස්සේ ඇතුලේ තියෙන මේ වෝටර් වේපර් ටික ඔක්කොම ඩෙන්ස් වෙලා එයා එක මේ ශ්‍රින්ක් වෙනවා. එයා ශ්‍රින්ක් වුණාන් පස්සේ එතන එනවා නෙගටිව් ප්‍රෙෂර් එක. එතකොට ක්‍රැක් වෙනවා.
අම්මා විදුරුවලේ මම මොකද චෙක් කරලා බලන්න දැන්. ආයිත් කුඩුනේ.
අප්පා. ඒ අර වෝල් එක තින් වැඩි. ඒක ඒ වෙන්නේ ඒක ශ්‍රින්ක් වෙනවා. ඒක අර ටෙස්ට් එකක් විදියට කරනවා ඒ කියන්නේ එයා ප්‍රෙෂර් එක පෙන්වන්නේ. ඒකට හේතුව එකක් ඔය තියෙන වැකුම් එක හරියට සීල් වැකුම් එකක් නෙමෙයි. ඕක සමහරක් වෙලාවට කරන ඔය මේ අපි බැරල් එකක් වගේ හීට් කරලා එකපාරට උඩින් අයිස් කැට වගේ මොන හරි දැම්මොත් බැරල් එක මැද්දෙන් කොලැප්ස් වෙනවා. ඒ කොලැප්ස් වෙන්නේ අර මේ ප්‍රෙෂර් ඩිෆරන්ස් එකකින් හින්දා. ප්‍රෙෂර් ඩිෆරන්ස් එක හැදෙන ඇතුළේ හැදෙන වැකියුම් එකක් වගේ. ඒක කොලැප්ස් වෙන්න බලන්න. හයිය මදි වුණාම පස්සේ. Right. So the question number 9. බලන්න එක මොකක්ද තියෙන්නේ? A piece of metal is heated 90 degrees of Celsius and dropped onto a calorimeter containing water at 30 degrees. The final temperature is 60 degrees of Celsius. A piece of the same metal of mass equal to half the mass of the first piece of metal is heated to 90 degrees of Celsius and dropped into an equivalent calorimeter containing the same original volume of water at 30 degrees Celsius. Then the final temperature is. ඒක අර mixture method එක. දෙකක් temperatures දෙක තියෙන දේ mix කරන. එතන මොකද්ද වෙන්නේ? The heat release should equal to the heat absorbed. අන්න ඒක තමයි දාන්න තියෙන්නේ. හදුවද? try කරන්න බෑ ටක් ගාලා. පොඩි වෙලාවක මිනිත් දෙකක් තුනක් ටක් ගාලා try කරන්න. අංකල් මට චුට්ටිය ලව දෙනවද මං ගන්න? Finish. Finish. You guys are making everyone sleepy and right? Did the ninth question? What happened? Right? It's a sleepy day, isn't it? Yeah, question number 9. Piece of metal. Yeah. Piece of metal is, even my eyes are hurting, that's other reason. A piece of metal is heated to 90 degrees of Celsius and dropped into a calorimeter containing water 30 degrees of Celsius. We'll just draw a structure of this. So, a piece of metal is dropped onto a calorimeter, right? Sort of a calorimeter is there and a metal is there and it's heated up to 90 degrees of Celsius and dropped onto the water, and the water is 30 degrees of Celsius, is it? It's 30 degrees of Celsius, right? And what else? The final temperature is 60 degrees. A piece of the same metal of mass equal to the half of the mass of the first piece of metal is heated to 90 degrees and dropped onto an equivalent calorimeter containing the same original volume. Okay, so here in the first time the temperature is 60 degrees of Celsius and another equivalent setup of calorimeter and water. That means this is 30 degrees Celsius as well. But the mass of, like half of a mass of this metal, that means like m over 2 is back again heated to 90 degrees of Celsius and dropped onto the water surface. And they are asking for the final temperature. They are asking for final temperature of this, right? So how are you going to find it? So you have to put 2 of the equations here. So the first equation, the heat released by the metal should equal to the heat released by the water, or the, let's say, take it as a system. Yeah, water, sorry, absorbed by the system, right? So heat released should equal to the heat absorbed, isn't it? So heat release should be mc theta of the metal. I'll take as m cm, and temperature difference in the first one is 90 minus 60, isn't it? 90 minus 60. Eh? නෑනේ මෙටල් එකේ heat එක බහින්න 90 වලින් නම් නෑ මෙටල් එක heat release කරනවනේ. ඇයි මෙටල් එකේ temperature එක බහින්නේ 90 වලින් නම් 60 වෙනවා නේ. water එකේ 30 වලින් නම් 60 වෙනකම් වැඩි වෙනවා නේ. So this is the heat released by the metal. This should equal to the heat absorbed by the complete system. That will be m what shall we take? M container, let's say, and the C container, and the temperature difference is how much? 60 minus 30 degrees of Celsius, right? And that is of the first system. What about the second system? Mass is actually half of it, right? But the specific heat capacity are same. Temperature difference 90 minus, we don't know the final temperature, we'll take it as theta. So it's 90 minus theta, right? 90 minus theta equals MC container temperature. Sorry, yeah, it's MC, mass of the container or the system. CC are the same. What about the temperature difference of the container? That will go from 30 to theta, that's 30 theta minus 30. So it's theta minus 30 degrees of Celsius, right? And that's the second equation, yeah? So you have to find theta. So you have to cancel all the other things out. To cancel all the other things out, better you divide, right? So you divide 1 by 2. That will cancel out this. MC to MC. Right? Everything will be cancelled out. This to this, this to this. Everything will be cancelled out. So what is left? This 2 will go to the up. That will be 2 times 90 minus 60 divided by 90 minus theta equals to 60 minus 30 divided by theta minus 30, right? So you have to simplify this back again. This will be 30, 30 times 2 is actually 60, and this is actually 30. So 30 to 30 cancels out anyway. So there is only 2 here. 90 minus theta is here. Theta minus 30 is here. So cross multiply it. 2 times theta minus 30 equals 90 minus theta. So it's 2 theta minus 60 equals 90 minus theta. Simplify the theta separately. Take minus theta to this side, that will be plus theta. 2 theta and plus theta will be 3 theta equals, take 90 minus 60 to the other side, that will be plus 60, 150 of a value. So if you divide it by 3, both the sides, theta will be 50 degrees of Celsius, right? 50 degrees of Celsius. Hands up those who have the answer correct. Whatever. No answers correct yet. අනේ. ඒක තියෙනවද බලන්න එපා. ආව තියෙනවා. ඒක වැරදි එකක් කොහොමද? Right. Should be this, yes.